Okay, thank you. So you should see my screen and my presentation now. So my name is Matthias Damm from Unified Automation. I'm deeply involved in OPC UA working group, especially the communication side for services and Part 4 and Part 14 pops up, but also like MQDT subgroup. And in OPC UA FX, I'm involved mainly in the prototyping working group to get everything working. Unified Automation is, maybe you know UA Expert, and you use that when you want to test some OPC UA clients, but we are mainly known as SDK vendor. So we provide development libraries for OPC UA, scaling from sensor level applications, sensor level devices, up to enterprise cloud applications, having different SDKs for the different levels and scaling. So what I want to talk today about is how OPC UA FX really works in detail for the communication establishment. But to go there, I want to stress that OPC UA FX is not a complete new development of everything. It builds on top of established features in OPC UA. And what is like the base functionality of OPC UA is to provide information from a product based on OPC UA information models, and then have client-server functionality to access that information. And at the end, what you have from a controller or from a field device is also an information model that is exposed as a server, and then like you have real-time data maybe that is exchanged between devices. So, but the starting point is always to have an OPC UA server for your product. And this is functionality that is stable and out there in the wild like since 10, 15 years. So we provide libraries to implement OPC UA servers in different languages, but also tooling to take information models, either standard models like the OPC UA FX model and application-specific models, and turn that into code to integrate your own product data into an OPC UA server. So even the OPC UA FX product development starts with developing an OPC UA server that exposes the information from your product. So what we added a while ago in the OPC UA big picture is another communication pattern, the pure pub/sub communication pattern. And Jim stressed that in his presentation on the first day. It allows us to separate like a control plane from data plane, and so pub/sub has a lot of different benefits for special use cases. So one that we will talk today about is controller communication or device communication, to make that very efficient cyclic communication possible. But there are much more use cases, like just a general integration into messaging systems, like MQTT message brokers, or in general to have a many-to-many communication that scales in much bigger environments. So how is this done in the libraries? So what we just added as an extension, because in the pub/sub model is just another communication model. It does not affect the information model. So the information you expose with your product does not change with pub/sub. It's just another communication capability of your product. And so in the most simple case, you add you add the pub/sub library functionality, link that to your product, and you have already your existing OPC UA server is already capable of doing OPC UA pub/sub communication. In a lot of use cases that we talk about in OPC UA FX, you want to have an efficient cyclic communication. So we offer also options to directly integrate with the messaging, so that you can directly transcode your process image data into messages sent over the wire. So there are optimization ways, and so this is something you have probably to do when you develop a product. But this has at that level has nothing to do with OPC UA FX. that is already something that is just a general communication capability of your product. And this pub/sub functionality is also out in products in SDKs since years already, but we have also a growing number of released products like controllers that support the pub/sub functionality. And we recently added that also to our .NET SDK as a feature. So now we come to the what is FX, OPC UA FX adding on top, and we need to talk about a few terms that you will find when you talk about OPC UA FX capabilities and functionalities. And the first term is automation component. So everything that is represented with OPC UA FX or exchanges information with OPC UA FX is an automation component. Could be a controller, so you can have controller communication. Could be a device, field device. Then you can have maybe controller device communication, or can be also like any compute node in the network. They all would be always represented as an automation component. And the automation component consists of an asset description, so describing the physical and components, but also software components in an automation component, and of functional entities. So there could be multiple functional entities in one automation component. The functional entity is representing some function in an automation component. So that is typically combined with input-output data. That's the relevant part for the communication side of OPC UA FX, is to have inputs and outputs that can be connected to other functional entities. Then you have typically some configuration data maybe that needs to be provided or set to configure the functional entity, and you have typically diagnostic information, and then the actual processing of the function inside the functional entity. But what you see outside is mainly input-output data, configuration data, and identification and diagnostic. So then the next term is the connections between functional entities. So the communication relation is always established between two functional entities, and one connection between two functional entities is always like the option to send data from functional entity A to functional entity B, and also on the way back. So we talk about different connection types in OPC UA FX. And if you compare that to plain pub/sub, so in a pure pub/sub environment, the publishers don't know anything about the subscribers. So they are configured to send certain data out to the network, either like as UDP multicast packages or to a MQTT broker. So you, as a publisher, you only know the network address, like the multicast UDP multicast address, or the broker address and the topic on the broker. And the subscribers, they know the publishers, but they only know where the address where they subscribe from and the description of the data sets they can receive, but they cannot directly influence the publisher. So the subscriber can just consume the data that is sent by the publishers, but has no direct influence, cannot modify the publisher, and can also not tell the publisher that it is available. In OPC UA FX, the typical setup is that you have a bidirectional communication. So either sending data in both directions, so input data from A to output data, output data of A to input data from B, and output data from B to input data from A. So that's called bidirectional connection. And the big benefit here is that you have still the cyclic efficient communication, but you also know the state of the communication partner. So do I receive data from my communication partner? So there is always knowledge about the other side. And even if the data flows only in one direction, that's what we call unidirectional connection with heartbeat. There is, even in the direction where there is no data, there are heartbeat messages sent, so there is no payload, but but the normal messaging with like sequence numbers and everything is ongoing. So even the component that does not receive data still knows about the state of the other component. There's a theoretical option of having also unidirectional connections, but then you lose the benefit of OPC UA FX to know the state of the other communication partner. So now what happens with these connections? Who creates them? And that's now you learn the last term here. It's the OPC UA FX connection manager. So the connection manager is responsible for establishing these cyclic communication relations between the different automation components and their functional entities. And this is done with OPC UA methods. So there is an established connections and close connections method, and the methods are used to establish these communication relations. And that's where I come back to Jim's presentation. So we have the control plane of OPC UA FX, the connection establishment and diagnostics. This is all done with client-server functionality. And then we have the data plane, that is the cyclic communication. And this is done with POP-sub cyclic communication, either UDP or Ethernet based with binary, or could be even go through MQTT brokers. But the typical communication pattern would be like, or the protocol would be UDP or layer 2 Ethernet. Okay, so let's go to my demo. So what I have as a demo is I have 3 automation components based on like I have one from our high performance SDK demo server that is released as a SDK and available for download. And then I have 2 demo servers from the C++ SDK. This is in the final release step, so that will be available very soon. And then I have UA Expert, a beta version that is also will be available soon. Has a OPC UA FX configuration plugin for OPC UA FX communication establishment and connection configuration. So what I will do with UA Expert is to create the configuration for the connection, but UA Expert can also do the diagnostics. The connection establishment as a connection manager, but that's not the real setup that you would use in a production environment. This is more like for setting up the initial configuration and testing the configuration. But then at the end, you would download this connection set to a connection manager. And one of the 2 C++ demo servers has also the connection manager functionality activated. So it can act as a connection manager. And I will also demonstrate how to download these connections to the connection manager and then to do the diagnostics for the connection state. So we have, I have UA Expert. I have like the three demo servers running here. That I will connect to each other. And the 3 demo servers are configured in a GDS. So all the security configuration is done from a central GDS component. I have already added 2 of the servers to the UA Expert project. So if you go to the OPC UA FX configuration view, you see 4 automation components. The reason is that we have in the demo servers, we have 2 automation components. One is the bottle controller, which is used like what was mentioned before in this demo walls from the OPC Foundation. And then we have also a second one with more functional entities that we use for plug-fest interoperability testing. So I will add the third one, just as usual here and I can go to the GDS and browse for the available servers. So I have these 2 already in, then I will add the third one here. Then I need to select the address I will use. So I use here local communication on my laptop. So I can just use the local loopback. So you see now 2 additional automation components added. from that third demo server. So the next thing is I add a connection configuration set. So there's a collection of FX connections. So we call that bottle line 1. Then we add the first connection. So that is from the automation component in the C++ server. And you see by just collecting the functional entity, it already fills in all the output variables. And that is another feature of OPC UA FX. You can have so-called pre-configured data sets. So if you do everything in the pre-engineering, you cannot only define like the inputs and outputs for your automation for your functional entity. You can already pre-configure the exact layout of your message with the variables in the order, and have that as part of your offline descriptor and exchanged and also online available in the server. So in this case, I just since this functionality has just one data set, then I just need to select the functional entity. So I take here the middle one, the server of the connection manager. And then I call this like washer to filling. And then I add a second connection from the middle server, like this is the connection manager. So if the connection manager functionality to the to the high performance SDK. You see here this one has some more functional entities. That's why I need to select the functional entity that I want to use here. But then again, there's one pre-configured data set, and I just need to get that all pre-selected. So there's a monitoring option, so I can look at the outputs and inputs. So these are the outputs of the first server and the inputs of the second one. And since I have not established the connections, there's no communication ongoing. So if I now go in here and say I will use the embedded connection manager embedded in UA Expert to test the connections before I download them to the connection manager. So it says both established. Then I go here. Then I see, okay, now the bottle ID and the information is forwarded to the next one. So the washer identification goes from the first to the second one. And then if we look at the second connection from the washer, from the filler to the capper, sorry, from the washer filler capper, okay. Then we have like the information moved on, and I disconnect here and maybe also use a better name here for filling to capping. Okay, and so in the last step, I also want to download now this to the connection manager for the operation. So I add a connection manager here, select the server that has the connection manager functionality exposed. And then I can download the connection set to my connection manager. And then I see here the diagnostic information. So the connection set is ready, but not established yet. So I can tell the connection manager to establish the communication, and then it tells me, yeah, everything worked. So the last action was established connection, succeeded. The connections are operational. There's no error at the moment. And so if I go back to the monitoring, so I see now the communication is again working between the automation components, or I can go back to the to disable. So you see now the remove success not established, and if I go back here, you see now the data is not forwarded to the next station. Okay, that was my demo for the connection establishment. And just as a summary, so in the SDK, we, like I said, we have client-server functionality since many years. We have pub/sub functionality since several years with the protocols implemented and the configuration options. We added recently the automation component integration into the high performance SDK and into the C++ SDK. So this is available, and that is what you need to implement, like to put OPC UA FX in a device, in the controller, in terms of what an automation component needs. What we are still working on is connection manager functionality, but there's also specification work that is currently completed that needs to be finished before we can release that functionality. So from a product development point of view, we have like the OPC UA FX information models that you need to feed into your product. You have your device description or like description of your automation component of your functional entity. That could be static if you have a simple device, or could be dynamically based on the configuration. But if it's static, you can create code for your product with UA Modeler. You can add the logic in your product with the SDK, and then you can have like a FX enabled product with libraries that are available today. And then you can use UA Expert also to test the product, like the connection establishment, and then go to certification. And that's probably one of the next things on the agenda. So thank you for listening.